Hello, the objective of this video is to learn about factoring polynomials by grouping. This process is only to be used for four-term polynomials. Now, I do have another video on this, but this one's a little more detailed than my previous video. Step one for factoring is factor out any GCF if there is one. This should be the first step in factoring any polynomial. Factor out a GCF. Step two, create smaller groups within the expression. This is usually done by grouping the first two terms and the last two terms together. Step three, factor out the GCF of each group individually. Step four, if the factors in the parentheses are the same, then factor the common binomial factor out, putting the GCFs together to form the second binomial factor. If they don't match, you may need to rearrange and try again, or the problem may be unfactorable. Chances are, in my class, with my 8th grade class here, it's going to end up being unfactorable, but on a standardized test, can't be certain. So you may need to rearrange to check it out. Step 5, determine if the remaining factors can be factored any further. Keep a close eye for the difference of two squares. Many times, one of the binomial factors in a four-term polynomial are going to end up being the difference of two squares, which you can factor further. Okay, before I go through an example of factoring a four-term polynomial by grouping, let's start with one that started off as two binomials. This is the binomial and this is the binomial. So we're going to go looking at these two binomials, and then we're going to actually multiply them. First times the first gives me 12x cubed. Outer is going to give me a negative 9x squared. Inner is going to give me a plus 4x. And the last is going to give me a negative 3. Now, the process for factoring a four-term polynomial by grouping is what's going to take this and bring us back to these two binomial factors. And the process says, first check for a GCF. There's no GCF here. Only factors of 4 are 1, 2, and 4, and 2 and 4 do not go into 3. So that's definitely no GCF there. We're going to group together the first two terms and the last two terms. So looking at the first two terms, we have 12x cubed minus 9x squared. Looking at those, there's a common factor between the 12 and the 9 of 3. They both have a common factor of 3. There is also a common factor between the x cubed and the x squared of x squared. So I'm going to divide both of those terms by the GCF that I found, the GCF of 3x squared. And that's going to give me, well, I have the 3x squared on the outside. Inside the parentheses, I have 12 divided by 3 is 4. X cubed divided by x squared is going to give me x. And negative 9 divided by 3 is going to give me a negative 3. And x squared divided by x squared is 1, which is just going to leave that as a 3. So now I close the parentheses there. I'm going to put a plus here because I'm almost assuming that I'm adding this part on here. Take the sign here, whatever whether it's adding or subtracting, consider that the sign for this term. So you're always going to be adding here. Now looking at that 4x minus 3, is there a common factor between 4 and 3? No. This one has an x, this term does not, so there's no common factor there. But we have to factor out some sort of common factor here. Well, the only common factor would be a 1. So we factor out a 1, which would leave us still with a 4x minus 3. All right, now from there, you'll notice that the 4x minus 3 was like our original 4x minus 3 here. We have that in both terms. So this set of stuff in the parentheses here is a common factor to both this term and this term. If it's a common factor to both this term and this term, we can do that reverse distributive property and pull out that 4x minus 3 from both terms. So now we have that. And what's left is the 3x squared plus 1, which is the same as our original right there. Let's look at this example using an algebraic, no numbers, just letters here. And if we look at this example here, we start off by grouping the first and second term and the second and third, third and fourth term together. Looking at ax minus ay, I have a common factor of a that I'm going to factor out, and it's going to leave me with x minus y. Plus, looking at bx minus by, I have a common factor of b. When I factor that out, I'll be left with x minus y. Notice again that this and this, the stuff in parentheses, this is one term. B times the x minus y in parentheses, that's now one term, and this is one term. And looking at these, you can see we have a common factor of x minus y. So we factor out the x minus y, and since it was a factor, we need to multiply it by what was left, which is the a plus b. So we get a plus b as the other binomial there. This is the factored version of our original 4-term polynomial. And if we do the FOIL process, first is going to give us the ax. Outer is going to give us the, outer is going to give us the bx. Inner is going to give us the negative ay. And the last is going to give us the negative by. So it does bring us back to that original. So a good way to double check to make sure whether you factor this correctly is to do that FOIL to see if it brings you back to the original. Okay, here's one example of another example of a polynomial with 4 terms that we're going to factor. First, check to see if there is a GCF. This has factors of 1, 3, 4, 2, and 6, but 4 does not have a factor of 3. It does not share any factors there, so this does not have any GCF. So I would go straight to grouping these together. Looking at these two terms here, here, and here, I see a GCF of 4x squared. Remember, when they share a common factor of the same variable to exponents, it's the lower exponent that's the GCF. Okay, after dividing both of those terms by 4x squared, I'm going to be left with 3x plus 1. Over here, the common factor, the only common factor here is going to be a 3. So I'm going to have a plus 3 times 3x plus 1. Now, a lot of people stop at this point. You can't stop at this point. You're not finished factoring. You need to take this common factor, the binomial of 3x plus 1, and you need to factor it out, which is going to give you 3x plus 1 and 4x squared plus 3. This goes to the first term, this goes to the second term of your second binomial. The first binomial is that common binomial to both terms. And if you FOIL it, you will find you go right back to that original expression there. Now, you could write it like this, or you could write it the way that my answer key has it, like this. Whether you put the 3x plus 1 first or second, it's still the same answer. Okay, here's another example. This time we're going to look for a GCF. There is no GCF here. 5 and 3 are both prime numbers, so there's definitely no GCF between them. All right, now we group the first two terms and the second two terms. The GCF in the first terms here has a 2x squared. Both of these numbers are even. That's where I get the 2 from here. The lower exponent on the variable, it's going to be the common GCF between the two terms there. What's left in there, if I divide the 10x cubed by 2x squared, I get 5x. Divide 6x by 2x squared, I'm going to get a plus 3. And you'll notice that there is no common factor here, but notice it happens to be the same as the binomial here. So again, I want to make sure that I do have a plus sign here. I have to have some sort of factor, so I'm going to pull out a factor of 1, which is not going to change that third and fourth terms here. This is still going to be a 5x plus 3. But now I've got a common term here, a common term here, common factor within those terms. So I can factor that out. I get 5x plus 3. And what's left over is that 2x squared plus 1. Which does match up with my answer key here. My answer key has this, different order, but the same answer. Okay, this time, in this example, we're going to see that there is actually a GCF. All 4 terms are even, so there's definitely a GCF of 2. The next highest even number will be 4, but 4 cannot go into 6, so that more than likely discounts that there. 6 can't go into all of those, so it can go into 8, but not. It can't go into 8, but it can go into some of the others here. But basically, the lowest, the GCF here happens to be 2. So we're going to pull out that factor of 2, which means these are all going to be divided by 2, giving us 3x cubed plus 4x squared plus 21x plus 28. All right, then we look to separate what's here into the factor by grouping here. We're going to group the first two and the second two terms there. In the first two terms here, the only common factor I see is that x squared. So we're going to pull out the x squared. Remember, we still have that 2 out there. Pull out the x squared, and we're going to be left with, after dividing by x squared, we're going to be left with 3x plus 4. Put a plus sign here. Look at these two terms. I see a common factor of 7. 7 goes to 21 and 28. So I pull out the common factor of 7, which means both of these are going to be divided by 7. It's going to give me 3x plus 4. Surprise, surprise. Now, you'll notice that we did end up getting the binomials in the parentheses here to be the same. So we're going to factor that out. And that's going to give us that 2 times the 3x plus 4 times what's left over as a second factor there, x squared plus 7. And that would be my final answer. Looking at my answer key here, they gave me the same answer, only they just, they did switch the order here, but that's fine. Okay, I can tell you there's going to be an added twist to this one. There is no GCF. So I go through the grouping here. All right, now I group those and I look for the common factor in these first two terms. That common factor is an x squared. Divide both by the x squared, and I'm going to get 2x plus 5. Now, I would put a plus sign right here, but I notice that both terms here are negative. So I'm going to pull out a -1, which I will also notice that that's going to give me the 2x plus 5 here, which is something I want to have. So I'm going to factor out a -1, which is going to give me 2x plus 5. Now I've got that common factor in these two terms here. Pull out the 2x plus 5. And I'm left with x squared minus 1. Now here's where the twist comes in. Notice that this last one here is a perfect square minus a perfect square. It's one of our special cases. It is a difference of squares. So we can actually factor that one further into x plus 1 and x minus 1. We also have that 2x plus 5 is still there. So this is the fully factored version of this polynomial. Got to be careful to look at the terms at the end here. You could find that you've missed a GCF. Maybe there's a GCF in there. Or in this case, you have a difference of squares. Difference of squares pop up quite often in here as an extra factoring factor there. So make sure you look for that. Okay, here, this one's got a twist too. Let's take a look here. We're going to start off by grouping. But when we group these, there is no common factor here and no common factor. Well, there's a common factor here, but with no common factor here, it's going to make things difficult. If I try factoring this, I'm going to end up getting just an x cubed minus 45. Maybe I'd factor out a 1 there. Over here, I'd have the common factor of x, and this would leave me with -9 plus 5x. Now, yes, I was able to pull out common factors, but is this anywhere looking like anything like this? No. Now, you might think it's not factorable at this point. However, if you look back, you'll notice that this is not written in that standard form with the decreasing exponents. It should be kind of a hint that something's off with the factoring there. So let's rewrite it in that form. We got x cubed plus 5x squared, moving the terms in order, x cubed and the 5x squared. Then comes the -9x. And then comes the minus 45. When I do that, and I group them now, the common factor in the first two is x squared, which leaves us with x plus 5. Here I would have a common factor of -9. I pull out the -9, and I'm going to be left with x plus 5. After having rearranged that and done this, we find that we do have a common binomial here that we can factor out. And that's going to give us x squared minus 9 times x plus 5. Now, you may think, oh, wow, all that work, we must be done now. Well, remember that trick I showed you a bit there? This is a difference of squares. So we're not quite finished. We have to factor that difference of squares to be an x plus 3 and an x minus 3. And then we have the x plus 5. And My answer, key answer is there. So you can see it does match up. Does it have to be exactly in this order? No. You can't have the changing of like the minus and the positive with the x minus 3 and x plus 5, but you can rewrite this as x plus 5, x minus 3, and then x plus 3. That's fine. You can't do the x minus 5 and then make this x plus 3 squared. That's not the same thing. That's no good. You can't change the sign, but you can change the positioning of these things. Okay, now, from what I can tell, this video does have what I believe are most of the catches that you may find inside of the little twists and turns you may find inside of factoring by grouping. Now, you may not see all these things. You may see some, you may see all. In my class in particular, I look to try and avoid giving this type of catch where there is more factoring here, but that doesn't mean it won't pop up on a standardized test. I hope this video was helpful. If it was, please send a comment or subscribe. Love to hear from you. I'm not doing this to try and get money. I do not monotonize my videos because I would prefer them not to have commercials. Thank you.